Section 7.5, Comparing two population proportions with confidence. Section 7.4, we talk about how to find the confidence interval for the population proportions. And in section 7.4, we only talk about one population. And these sessions, we will be working on two population proportions. And we need to know how to construct the confidence interval for the difference of the two population proportions. Look at this example. In 2002, there's a random sample of 1,500 people suggests that 43% of Americans approve of stem cell research. So we have, this is a 2002, and then we do the random sample of n equal to 1,500 people. They suggest that 43% of Americans approve of stem cell research in. So we have the sample proportion equal to 43%. And then in the 2009, couple years later, a new poll of a different sample of 1,500 people found that 58% approve. And then my sample proportion become 58%. So did American opinion really change, or do the sample proportion differ just by chance? Could the population proportion be the same even though the sample proportions are different? So you could see we are comparing like two different populations. One is in 2002, one is in 2009. Okay, first we're gonna let P1 will be the population proportion of Americans approve of STEM research in 2002. Okay, and then we're gonna let P2 the same thing here, but this time it's gonna be in 2009. So we have the first population, population 1 and population 2. Since in the 2002, we call this as a P1. So for the sample size, we're gonna say N1 in here, sample proportion 1. And this is gonna be N2, sample proportion of P2 here. Okay, and then we want to find it out, did American opinion really change? Do they change like after a couple years, or the sample proportion differ just by chance? So this is what we want to do. We want to find the difference of P1 minus P2. We want to see what is the difference between these two population proportion. Will they equal to each other? Will be greater or less than? This is what we want to know. Find the difference of the P1 minus P2 of the confidence interval. Okay, so we want to know, will it be equal to each other, or P1 is going to be greater, or P1 is going to be less than? Okay, so for these sessions, we are working on the confidence interval with two population proportions. Even if two population proportions are equal, the sample proportion drawn from these populations are usually different. Okay, so even though they're equal to each other, but like the sample proportion, the p hat drawn from this population are usually different. They should be different from each other. Confidence interval are one method for determining whether different sample proportion indicates there are real difference in the population proportion. Later on, we're going to introduce hypothesis testing. That is another method to determine whether the different sample proportion indicate there are real difference. Okay, so these sessions, we're going to focus on the confidence interval with the difference of the population proportion. Basic approach. Our comparison of two population proportion will be based on the statistic. You could see this is talking about the difference between the sample proportion 1 and the sample proportion of 2. And this statistic is used to estimate the difference between two population proportions. Okay, the idea is pretty similar to the section 7.4. We use the sample proportion to estimate the population proportion. For these sessions, since we have two different populations, so we're gonna find the difference of sample proportion 1 and the sample of proportion 2 to estimate the difference of the population proportion 1 and the population proportion 2. So now we're gonna try how to find the confidence interval for the difference in the proportion P1 and the P2. And then we want to check if the 0 is included in the interval. Remember, here I showed you guys, this is what we want to find out. Is P1 equal to P2, or P1 greater than P2, or P1 less than the P2? So first, we want to see, when you find the confidence interval, do they have including the 0 here? If they do including the 0 here, means P1 will be equal to P2. If 0 is not in the interval, the confidence intervals tells us how much greater one of the proportion may be than the other. I'm gonna explain this part later, okay? General method, confidence interval for two proportions has the same structure as the confidence interval for one proportion. This is pretty similar. If you remember the section 7.4, we do have the sample proportion plus minus z star and then times standard error. Okay, and since this time we involve two populations, so we do have the difference of sample proportion 1 and the sample proportion 2. And then plus minus C star times standard error. And this guy, you will have a different formula. Okay, it involving like the sample proportion 1 and the sample proportion 2. And same idea for the C star, we will be getting this confidence level. Okay, it depends on your confidence level. Will it be 90%, 93%, 95%, or 99%? As we did for one proportion, putting these two together, we see the confidence interval for the difference of two proportion is. So this is the formula for the difference of two proportion. The difference of P1 and P2. Okay, that will be in between these two guys. Okay, this table will be explaining the difference of the confidence interval for P1 minus P2. Will P1 equal to P2, or P1 greater than P2, or P1 less than P2? Okay, I'm gonna give you guys some example. The difference of the P1 and the P2. P1 minus P2. Let's say I find it out the confidence interval of P1 minus P2 will be equal to -2 to 3. Okay, I just make up some numbers. Okay, so you could see that if I draw it from the number 9, I have a -2, -1, 0, 1, 2, 3. And that means the difference of the population proportion will be in between here. All right, any number within this interval. So you could see that will be including the 0. Okay, so can I write it like this? So P1 minus P2, possibly it can be equal to 0. All right, because 0 will be the number within the intervals here. And then I have this equation. So when I do the math here, P1 will be equal to P2. That means a couple years later, the population of the proportion still the same thing. Okay, they are equal to each other. Okay, so this is gonna be the case 1. The first one here contains 0. The difference of population proportion is not significantly large. which indicates that P1 equal to P2. This is the idea. Okay, number 2. Both values are positive. So meaning that the difference of the population proportion will only contains positive numbers. Okay, so same idea, 1, 2, 3, 4. So this time, the difference of population proportion will be within this range. Okay, then I would say P1 minus P2 equal to, I could pick any number within this interval. So let me pick the 3 here. Okay, and then I'm gonna add P2 for both sides. So P1 equal to P2 plus 3. Okay, from this equation, think about it. Will be P1 is greater or P2 is greater? If P1 is equal to 4, then P2 has to be equal to 1, right? So it satisfies this equation, right? So you're gonna know P1 has to be greater than P2. Okay, so this is gonna be case 2. If your confidence interval for the two populations is gonna be within the positive values, then P1 has to be greater than P2. Okay, now number 3. This time, both values are negative. So P1 minus P2, it can be within the negative values. Okay, so that will be in between negative 4 to negative 1. Okay, the numbers is gonna be in between here. So I can have P1 minus P2 equal to any number within this range. Let's say I'm gonna put negative 2 here. And then I'm gonna take care of the negative numbers. I'm gonna plus 2 for both sides, plus the P2 for both sides. You're gonna get this equation. So obviously this time P1 will be less than P2. So after you construct the confidence interval for two populations, you should be able to compare, will the population proportion be changed? Will they equal to each other, greater than or less than? Okay, we have a complicated formula here. How you find the standard error, how you construct the confidence interval. You could use the calculator, okay, to calculate it. And this is going to be your instruction how to use the TI-84 calculator to construct the confidence interval for the difference of two population proportions. And before that, you need to checking the 4 conditions, okay, 4 conditions. First one, random and independent samples. Both samples are randomly drawn from their population and are independent of each other. Okay, you can't draw the sample from the previous populations. Okay, independent of each other. Second, large samples. Both sample sizes are large enough that at least 10 success and 10 failure. So same idea, same formula here. You may just need to separate two of them, population 1 and the population 2. It has to be greater than or equal to 10. Number 3, big population. If the samples are collected without replacement, both population size must be at least 10 times bigger than their sample. Okay, large sample size. Number 4, independent samples. Samples must be independent of each other. This means there can be no relationship between the objects in one sample and the objects in the other. Okay, 4 conditions. Okay, now let's try to do the example together. In August 2014, the poll asked the random samples of 2,002 Americans and 3,748 scientists if the space station has been a good investment for the United States. Of the non-scientist poll, 64% say that the space station has been a good investment. Of the science poll, 68% say that the space station has been a good investment. Construct a 95% confidence interval for the difference between the proportion of scientists and non-scientists who believe the space station has been good investment for the United States. Based on your confidence interval, is there a difference in the population proportions? Explain. Check conditions. Okay, so we do have two populations here. First, we want to check the condition. But before that, you have to state which one is going to be your population 1, which one is going to be your population 2. So first, I want you guys highlight this part. Let the P1 be the proportion of non-scientists, and we let the P2 be the proportion of scientists. Okay, you can let it different. You can let P1 be the scientist and let the P2 be non-scientists. Then your result may be different from mine, okay? But make sure on the exam, I want to see this one. I will have this table here. I want you guys to fill it in, okay? This is non-scientists. You have the P1, P2, and I want you guys write it down. What is the sample size? What is the N? What is the number of success? So N1 will be 2002, right? How about N2, the scientists? That'll be 3,748. Okay, now I want you guys calculate the number of success. So remember this formula? The number of success equal to the sample size times the P1 here. So we have these two guys here already. Use your calculator. You're gonna get 1,281. Okay, find out the X2. You should get 2,549. Okay, right? Now, we're gonna check the conditions. First, random and independent. Second one, large samples. So we're gonna plug into this formula. Make sure all of them is gonna be greater than or equal to 10. Okay, so you have an N1 times the P1, which is gonna be your X in here actually. And then times the failure, do the population 2. Okay, this is good, right? We do have a large sample size. All of them is going to be greater than 10 here. Okay, condition 3. We have the big populations. Population are at least 10 times greater than the sample size. Number 4, independent samples. Okay, right? Checking all the conditions. Now, you guys can use the technology, use your calculator to construct the confidence interval. For the section 7.4, one population proportion, I need you guys to show me all your work with the formula, how to construct the confidence interval. But for the section 7.5, since the formula is a little bit complicated, I let you guys use the calculator. But make sure I need to see this. Okay, state the P1, P2, check the condition. It's better you could tell me what is your P1, P2, N1, N2, and X1, X2. Okay, this is what I get. I'm gonna show you guys with my calculator. Okay, go back to this slide. We're gonna go to the stat, go to the test, go down. We're gonna choose 2 population proportion, Z interval, C confidence interval. 1 proportion, C interval. This is talking about section 7.4. 2 population proportion, C interval. That would be the section 7.5. Okay, we have this table here. X1, 1,281, N1, 2002, X2, 2,549, N2, 3,748. And then we are working on 95% confidence interval. So 0.95. Go to calculate. Okay, check your work. You should have 0.066 and 0.0144 here. Okay, make sure you're including this guy, the P1 minus P2 here. You could write your confidence interval with the inequality, just like this guy. Or write it down, P1 minus P2 equal to this guy. After we know how to construct the confidence interval of the difference between the population 1 and the population 2, now we're gonna solve. Will they be equal to each other or less than or greater than? Okay, look at this confidence interval. Both of them contains negative values. Okay, so negative values, we're gonna go back here. Both values are negative. So that will be P1 will be less than P2. Okay? So in other words, the proportion of non-scientists who believe the space station has been a good investment is less than the proportion of scientists who believe so. The possible values for the difference in the population proportions lie between 1.4% and 6.6%. Okay, so we write it down here. We times 100% in here. And then the negative here is just telling you that P1 is going to be less than P2. Try this example. Okay, this one, they already have you guys state the P1 and the P2, right? And they construct the 95% confidence interval for the difference in the population proportion. They do have the answer here already. They just want to know, does this interval indicate there is a difference in the support of thinking between these two states? So look at this confidence interval. One negative, one positive. That means they will be including the zero, right? When they including the zero means P1 will be equal to the P2. So we're gonna say since they contain zero, we can conclude there is no significant difference. No significant difference means they are equal to each other. That's it.